Hi, welcome to SPE Live ATCE edition. My name is Nils Korgerson-Lowe and I am your host for today. Today we are talking about well integrity, protecting your investment over the life of the well. This topic is one of the technical sessions at the upcoming SPE Annual Technical Conference, and shortly I'll be talking with the session co-chair Albert McSpadden and authors Mark Glazer and Dr. Nathan Welsh. Firstly, a quick thank you to our sponsor, the SPE Foundation, for making SPE Live part possible. So without further ado, let's introduce our guests. So Albert is VP of R&D at Altus Well Experts and has been with the company for over 15 years, involved in complex well analysis, advanced casing and tubing design, and has led a joint industry project for well thermal simulation. He has a master's degree in mathematics and computer science from Texas Tech. Mark is a global advisor for Halliburton's Multilateral technology. He graduated from the University of Houston with a degree in mechanical engineering and a master's degree in finance. He has authored several technical papers and articles and has several patents to his name. And finally, joining the team, Nathan is a scientist at Los Alamos National Laboratory, serving as a lead for the EES-14 Microfluidics Laboratory. He obtained his PhD from Imperial College London, studying fluid flow processes in Caprock. Welcome, gentlemen. Thank you for joining me today. It's great to see you all.
Glad to be here.
Glad to be here.
Yeah, thanks for having me along.
So I'm very excited to be talking to you all about this session on well integrity. Albert, perhaps as session co-chair, let's start with you. You know, the content, the technical content for ATCE was locked down many months ago. But obviously, the pandemic has changed our world quite significantly, and in particular, the delivery. So what challenges have you faced in repositioning the session for a virtual audience?
Well, as they all say, it's been unprecedented, right? It's a wild and woolly ride. So we went through all these changes. As you said, we were going to had our program. We're going to be in Denver. And then when they said, uh-oh, well, it may have to be in Houston. It may be partly virtual. And then finally, no, it's going to be virtual. So at each stage, the authors are asking, gee, I don't know if I'm going to be able to make it. Travel restrictions or closed borders. There's the SPE no paper, no podium policy. So do I even complete this paper? So we were just trying, the committee, the members were trying to interact with the authors, keep them posted, let them know, it's a fluid situation. We're literally figuring this out as we go. And just letting them know, look, keep working on your papers, complete the drafts, start the presentations, and we will make sure that we get a good resolution. And everybody was a good soldier and kept at it, and we kept all our ducks in a row. Certainly, I would have to say we owe a big thanks, once again, bigger than usual, to Cindy Madding, the SPE event coordinator, and then also our technical chair, Junichi Sugiura, who they've really tried to keep everybody on the same page. Technically, for our session, the biggest hurdle is now, for the first time, a lot of authors were asked to prepare a complete audio-visual recording, pre-recorded version of their presentation, along with the PowerPoint slides, and present that and turn it in several weeks earlier than expected. So that was a technical hurdle for some. Some of our authors had never done that before, and so we helped navigate the different ways to do it. And I think it all worked out. Everybody pretty much settled on doing it in PowerPoint, exporting their files. We got through that. A few authors had some issues with getting their approvals, which was a little quicker deadline, pushed that envelope, but we got it all done. So
yeah, that's good to hear. And from many other virtual conferences that we've had prior to ATCE, we've seen that the level of presentation is that much higher because people are pre-recording and have that ability to re-record.
Yes.
So,
yes.
I mean, that's something to look forward to, is those high quality presentations. We also see that the quality of the Q&A also is quite significant in these situations. So that kind of leads me on to the next question, really. So give us an overview of your session on well integrity.
So we have 6 papers, and it's really a very well-rounded, very diverse session. Okay, we're attacking the topic of well integrity from various vantage points. We start off with a couple of papers that are looking at the oil field chemistry, looking at zonal isolation, water shutoff with the polymers, and then we've got this paper we're going to talk about where they've done research on a CO2 activated hydrogel for well remediation. Then from chemical, we go on to another topic that's quite current, and that's all the aspect of casing failures, casing deformation, especially in the unconventionals, a very, very common topic. So we've got some data analytics, machine learning, where we're looking at the pressure profiles during frac jobs to intelligently identify, classify, maybe mitigate casing failures. Then we move on to some mechanical approaches where we look at the design and assessment of non-damaging frac plugs that will not damage the casing or release during the course of the job. Then interestingly, we flip the coin, change the narrative, and look at doing casing deformation really on purpose, looking at a special tool to radially expand the casing as a way of mitigating, say, surface casing vent flows or methane leaks, microannuli in the outer cement sheath. And then we wrap up with a look at a more mature technology, multilateral well architecture, and pairing it with newer technologies such as intelligent well systems and inflow control devices for sort of a comprehensive approach. So a nice range of technical topics on well integrity.
Wow, that is quite the session. I just made a note of all the cool stuff you got coming up. So, everything from oil field chemistry and zonal isolation to casing failures and unconventionals, mechanical approaches for frac plugs, expandable casing deformation for zonal isolation as well, yes. And then, as you say at the end there, the multilateral weld technology, with the newer technology. So a fun-packed, very interesting, exciting session coming up.
We should have something for everybody. So.
Exactly, yeah, something for everybody. So, what do you hope to be the big takeaways for people attending the session?
Well, for me, well integrity is a topic near and dear to my heart. It touches on economics, so we spend all this money getting a well in the ground. Well, it had better fulfill its purpose for its full design life. That well is an asset, and we want to. If we have a failure, we lose production. If we lose access to the well bore, well, we've compromised, right? The whole show, the economics. Also, that well is a liability. We're very mindful of the health, safety, and environment issues, HSE, so we want to make sure the barriers are in place, confine the wellbore fluids and pressures. And we're also talking a lot more about sustainability, all right? And we talk about now environment, safety, government, right? So that certainly goes along with HSE, and well integrity is a big part of all of these. Even sustainability now, as we start to talk about things like carbon CO2 sequestration, CCUS, or disposals. Well integrity is there. We just had a SPE webinar on that topic today, I believe. And moving forward, even oil and gas is starting to talk about geothermal, right? Pivoting to geothermal. Well, that means drilling wells in very challenging subsurface environments that need to do their job for 30 years in high temperatures. So again, well integrity comes back again. So I think it's a very relevant topic that is going to stay relevant for many years, and you'll see different ways to attack the problem.
Absolutely, yeah. I really echo your sentiments there, particularly, as you say, it is life of well management, right? So making sure it's, you have that design life fully understood for the operating conditions of the well. And then obviously, you're saying the return on investments, minimizing liabilities, particularly around sustainability and safety issues, and how that's coming across to well integrity for CCUS applications and also now geothermal applications. So some very important pieces to take away from the session, as ever, on well integrity. And in a way that kind of nicely brings us over to Mark and your paper. You have the paper at the end of the session on multilateral well technology. So your paper, simulations demonstrate the benefits of continuous improvement in multilateral wells in the Norwegian Sea. Now, I know many Norwegian petroleum engineers would argue they are the true innovators in horizontal drilling and multilateral well technology, stretching back to the late 80s, early 90s, and the development of the Troll oil field. So without giving away the ending of your presentation and technical paper, can you give us a bit of an overview?
Well, yeah, this paper that I'm presenting was a continuation of a paper I presented last year at Calgary, and that we took a evolution of a multilateral system that's been used for 19 years on the Troll field. And we described it last year, but then everything we have is empirical with how it's doing. How do you compare the step changes we've made over the last 19 years to really see the quantify the improvements? And so with it, we've taken intelligent completions and inflow control devices, and we've all put them together, holding as much constant as we could. We constructed a reservoir to simulate the Troll, and then ran a pump model to actually quantify those improvements. And what we're looking for, of course, is an increase in oil production and a decrease in the water production for a number of years.
Okay, fantastic. So yeah, so I'm getting from that the model that you use, which I guess is quite using that pump model, and looking for the increased oil production versus reduced water production, which is critical on Troll, given the thinness, if you want, of the oil layer that they're trying to extract. Right. So 19 years of history here on Troll oil field. Again, without giving away too much of your paper, what have you been able to capture in terms of design changes from your analysis?
As you make the step changes, the first thing you do is get a base. Once we had the base system installed and it was functioning and the installation was going according to plan, we were able to look at what were the needs of the operator and what did the reservoir need to produce it more fully, to increase the percentage of oil that they were eventually going to get out of it. And so with that, we looked at as intelligent completions came into the mix in inflow control devices. And so we've used the multilateral system, which increases your reservoir exposure, to work with those to increase the functionality in the entire system. So it's not just multilaterals by itself, but it's as part of a package to help the operator get more out of the well. And with the simulations now, you can not only look at what you've gotten, but you can project forward. With if I shut this lateral in, if it starts watering out, what's going to happen to my production going forward from the other laterals and things like that. So the simulations has really added a lot to being able to actively manage the well.
That's fascinating. So thank you for that. That's really interesting to hear how you can look ahead and help you with the reservoir and management and the well production profile. In your analysis, did you also look at the reliability of the various technologies and how they impact overall reservoir management? Yes,
especially since Troll is a subsea field. So, you know, to do intervention into it is extremely expensive if I want to do mechanical intervention. So the reliability of the different systems is a must to consider. And what we've shown with that same system, having installed them for 19 years, is that the reliability has increased where it's in the high 99% or so for the multilateral installation, and then gaining in the intelligent completions and the inflow control devices.
Right, Okay. And another aspect, I guess, that's important is what about the location of the multilateral junctions? I mean, I recall from my days working on Troll is either in the reservoir or just above the reservoir. So has the analysis indicated any preferred locations around that, or implications of where the junctions are located?
Well, they made a decision to install the junction in the reservoir. Now, the benefit of that, of course, is that you're able to reduce the pressure differential across each leg, each lateral. And so you're better able to design functionality into the system versus trying to achieve a differential pressure ability, which would not be used. So it's a ranking your needs.
Okay. So, all right. So that's really about how to drive the most optimal production out of the each lateral then in terms of placement of that junctions. So that's really interesting. I think I'm really going to be tuning into your presentation because it's near and dear to my heart. So, yeah, very much looking forward to that. So, Nathan, I'm going to tell you now, your looking at a very different aspect of well integrity, this time in terms of, I guess, zonal isolation. And your paper is on the effectiveness of a smart hydrogel in well leakage remediation. So, again, what's been the objective of your work around this?
Yeah. So just kind of the objective of what we were trying to accomplish is, and I guess just in the paper, this is kind of the culmination of several years that we've been working towards this. So for looking at well integrity in terms of kind of the remediation aspect, so if you have leakage that's occurring, you can get into a scenario where current technologies for like cement squeezes aren't capable of sealing kind of the leakage that you're seeing. So these are very small leaks. You can tell that they're there, but you can't necessarily kind of go in and try and squeeze cement into them or anything like that to kind of seal up the leakage. So there's a need for this technology just to solve these kind of leakage problems. And what we wanted to look at was, could we develop something? So we have a team of, we have a chemist and kind of our geoscience group. We've been working on this project where we needed something that we can inject into these wells, and they can. Sorry. We need something that we can inject into these wells, that we could then kind of after the fact, so we have really high injectivity, and then we activate this gel with CO2, and that kind of will finally kind of stabilize this seal and then kind of bring the leakage under control.
Okay, thanks. So that's the background to it. So now you have smart in your title, smart hydrogels. So what is the smart piece of the technology?
So the smart piece, we pretty much just labeled for, since it is kind of, it does have this built-in trigger. So when you inject this into, if you're just in kind of a very non-acidic hydrocarbon well, these particles won't activate at all. So they have to be triggered using CO2 kind of preferably, and that causes them to form a seal. Whereas before that, the injectivity is actually quite good.
Okay, so the trigger mechanism is the CO2, and then so that provides you that flexibility in the technology, I guess. And then you were describing earlier, it's really aimed at these very small, low-rate leakages, I guess. So long-term integrity of the well is really, I guess, one of the big pieces to the work, right? Is that correct?
Yeah. And one of the things that we're focusing on, I mean, just in kind of forward-looking, if CO2 sequestration does really start to take off, not only are you worried about kind of your injection well or your production wells, but you also have abandoned wells that are kind of located around your reservoir potentially. And this would allow you to kind of go back in, and if you need to seal any of those abandoned wells, you can use this technology. And then if it's in the case of a sequestration project, the CO2 is already there. So if you have a leak that's going through your well casing, You inject this gel, and then the CO2 that's leaking through will act as the trigger itself. So you don't even have to inject CO2. You can just use the CO2 that's leaking.
That's fantastic to hear. I mean, that's some big challenges up ahead for the industry, sort of not only the CCUS application, but also you mentioned the orphan well problem that we have within the industry as to how do we ensure that those wells, those abandoned wells, remain sealed. So obviously a critical type of technology. Can you explain a little bit about your experimental approach behind the technology?
Yeah. So we have, and just kind of what I have described in my paper. So we started off with laboratory tests. So we synthesized this gel from scratch. So we have a chemist on team that's synthesizing the gel for us. And then we take that, we did some initial kind of quality control tests, just looking at the reaction with CO2. And then we took this and we actually have a high pressure, high temperature microfluidics capability at Los Alamos. So I'm the lead of that laboratory. So working in that environment, you can make direct observations, looking at pretty much exactly how these gel particles are behaving in the subsurface. And from that, we can kind of build best practices in terms of kind of how you deploy it into the field. So that's been really powerful in terms of kind of looking at being able to see directly what's going on with this smart gel, and then being able to use what we're doing in the field.
Oh, that's great. So real innovative technology, and also I guess an innovative way of testing the technology to demonstrate its applicability. So now turning to all three of you, let's maybe spend a few moments talking about well integrity. You know, today's environment is cost sensitive. It's one of the most well integrity is more important than ever. So, you know, trying to minimize as much as possible cost to workers. What kind of changes do you sort of anticipate in the next 12 to 18 months around well integrity technologies and practices? Perhaps start with you, Albert.
Well, I think obviously one of the aspects, and something that's a lot of a discussion going on in the area of casing deformation, is just understanding the causes. And there's been back and forth. I know we're have a casing deformation summit coming up, but there's still work to be done, I believe, in really understanding what's going on. There's been a lot of look at more instrumentation, even the use of distributed fiber optics and things like that. Maybe using some of the technology we're putting in with these intelligent well systems and inflow control devices. Just having a better understanding of what's going on down in the subsurface, so that we know what is the problem we're dealing with, and therefore what kind of mitigation approaches might be most suitable. And I think for something like long-term sequestration, you know, where we put in a lot of CO2 down in the ground and we want it to stay there for a very, very long time, then maybe even some of the investment to have long-term downhole monitoring could be very important to guaranteeing and sort of justifying the whole effort from a sustainability point of view. That's things that come to my mind off the bat.
Oh yeah, thanks. So that's some really interesting points to make about the instrumentation. So, Mark, you know, you're dealing with intelligent well completions. You know, how much further do you think you could have evolved the technology had you had more instrumentation? And then, you know, what's that mean in the future?
It comes down to data. You know, we've talked about big data for years, and using that data effectively, where you can actually make a closed loop system for each well, where it's reading all the sensors you have placed in the wellbore, and then using AI perhaps to automatically adjust the inflow control valves so that you can choke back or open up different laterals to more effectively flow your wells and produce them. But taking kind of that human element out, where it's not that constant human involved in the monitoring, but letting a program control it.
Yeah, that's certainly an attractive proposition, a step forward in terms of allowing a more sort of dynamic control of the well performance based on AI and instrumentation. On the flip side of that, turning to you, Nathan, the sequestration piece, and I guess the bit that never really been talked about yet is the long-term integrity of wells that are used for carbon dioxide injection. So what's your thoughts around instrumentation, particularly from your perspective, looking at these low-rate, small-volume leakages and long-term integrity?
Yeah, I guess I'll say just what I can add in terms of kind of whole instrumentation and things like that. I know there's quite a few projects that are going on around the national lab. I'm not necessarily directly involved with them, but I know having a passive system that can show if you have leakage occurring or anything like that would definitely kind of provide reassurance to a lot of maybe any sort of kind of overwatch for sequestration projects, just kind of being able to tell if you have leakage occurring, or whether the CO2 you pump down stays in place. I mean, that's a pretty hefty goal, especially on the time frames of achieving.
Yeah, absolutely. Yeah. Again, it comes back to that long-term integrity for the wells, as in any production well also. So, gentlemen, a really good conversation, even a short conversation at this stage, but I'm very much, a lot of promise for the technical session itself at ATCE, so on well integrity. So, like I said earlier, very much looking forward to listening and watching your session, and inviting everybody in the audience here to join your session on well integrity, protecting your investment over the lifetime of the well. So that's going to be broadcast on Wednesday, the 28th October, from 8:30 in the morning to 12 noon, Houston time, Central Time, session room 4. So for the audience, please go and check out ATCE. And gentlemen, thank you very much for joining us today and talking about your session and your papers so passionately. It's going to be an awesome session. So thank you.
Thank you. Come and see us.
Greatly. Yeah, absolutely. Thanks, guys.